So we're here today to talk about engineering. Leyton is a consulting firm that that we consult specifically on tax credits. So we have the pleasure of really getting to learn a lot about businesses. One of our sectors we focus on is engineering, and so we get to really hone in on a lot of the cool stuff they're doing. So the plan today is to discuss. Sorry, I'm trying to time this with clicking. There we go. Is to hear from our experts. So we have Jenna Kubiak from our engineering team. She has a background in civil engineering and she worked in construction management at Skanska prior to joining us here at Leyton. And then we also have on our panel today Evangelia Dislaki. And Evangelia is a mechanical engineer with a master's in robotics and a PhD in material science. So clearly a wealth of expertise. And then last but not least on our panel today, we have Riley Sager, who has a background in mechanical engineering. And he previously worked at Raytheon and Johnson & Johnson within the engineering department. So mechanical engineering seems to be the theme today. And we're going to be hearing some stories and interesting projects that the team has had the opportunity to work on. So the reason that we have these great people all here together today is because our focus is, as a firm, is to help businesses continue to grow. And one really great way to do that is with some government incentives. So the research and development tax credit has really been the backbone of allowing businesses to innovate. It was originally introduced back in the 80s, and back then it was utilized by bigger companies like Google, Apple, who were creating something new for an entire industry. And then back in 2015, there were some changes to the code, and it opened it up to all industries and all business sizes. So now the work that's being done within a business just has to be new to their business, not to an industry, which really allows for what most folks consider pretty minor projects or minor improvements to actually have qualifying elements for the R&D tax credit. So that's what we'll run you guys through today. And just overall, what the R&D tax credit does is it offsets income tax liability through a dollar for dollar tax credit. So it truly is like putting cash back in your business, back in your pocket. If you've never claimed before, you can look back by 3 years. And that's exactly what we'll help with. We'll look at your projects over the past 3 years and identify what's qualified. So broadly speaking, some of the activities that qualify for this tax credit within the engineering industry are listed here. I think the key word that you'll see in many of these examples is improving, designing, evaluating, developing. So if you guys are doing those things within a business, you're doing R&D, and it's worth talking about. So there have recently been some changes to the R&D tax credit legislation. One of the really important things is that it's now required when filing the R&D tax credit that you submit an activities report. And that's much of what the work of our engineering team here does. We work with the company to identify the activities that qualify for the R&D credit, and then we author a comprehensive report to go along with that when filing. That's always been something that we've done, but now the IRS requires it. So you got to make sure you do it right on the first try, because you can't go back and try again. They're giving a one-time option. So it is important to do it correctly. So we want to share some of the work and the innovative products that we have worked on. There are some instances in which I believe we can share the name of the company. For the most part, not, given the nature of the work, innovation. So it's not necessarily something that is shared, but the intent is for this to be a nice conversation. If you have questions, please pop them in the chat. And I believe if you guys would like to learn more, or if you have to run and you can't listen to the presentation, we'll include a link in the chat box and you can schedule time to meet with one of the team members here at Leyton. So the first example we have to talk about today is an HVAC design company that Riley worked on. So Riley, tell us a little bit about what the project was and what you liked about it.
Thanks, Maggie. So my name's Riley, and today I'm just going to give a brief example illustrating some work with an engineering company that worked to fill a high performance need for HVAC systems that is able to provide quality air in an effective way. So the project, the first part of the project was involved with identifying a primary business component, which in this case was a MEP system aimed at increasing energy efficiency, improving ventilation, and promoting increased structural safety within the building. The project also needed to revolve around the second part of the four-part test, which states that the company needs to be applying the principles of engineering or the hard sciences. So in the specific example with the HVAC company, since nearly all their work revolved around engineering and architecture, it was able to comply with the technicality requirement. So in the development of a new MEP system, we were able to identify the following uncertainties. We had uncertainty as to the ideal balance between durability and performance of the system. We had some uncertainty as to the varying levels of ventilation needs based on the occupancy of the room. And we had uncertainty as to the appropriate design to reach improved energy performance and improved efficiency metrics. So, knowing these uncertainties in the development of an MEP system, the company needed to consider the following options for ventilation. The first was the design of a large circulation fan that recycled air within the building. The second was the design of a large exhaust fan that pulled hot air through the top of the building. And the third was the design of an energy recovery ventilator concept for a passive MEP system. So if the project in question can abide by all four parts of the test, it can be qualified as a research expense for the R&D tax credit. Now I'm going to pass it over to Jenna to review an example with a manufacturing client.
Thanks, Riley. A pretty cool project that I worked on was a client that came to us in the food processing realm. They came thinking that, they had a few projects, they were developing a few new components, a few new mechanical systems. And kind of as our discussions with them went further along, we kind of realized that, they were developing a whole breadth of new systems for washing different types of produce, new different conveyor belts, fabrication units for all different types of fruits and vegetables and other kind of food products. Essentially, kind of as we were looking at this, we realized that, each of those systems itself was different. They each kind of had different performance metrics they needed to meet, different output capacities, and lots of different, elements that were kind of trying to be achieved for each new product. And, as we went along, it kind of became clear that for each of these new systems, the company was developing prototypes for these systems. And that turned out to be really beneficial for the company, not only in terms of the qualified time that they spent kind of designing these new systems, testing, and kind of evaluating the functionality of the systems, but also in terms of the material costs that could be qualified for the credit. In developing the prototypes, any of those materials that were kind of consumed in the development of, a conveyor belt system or of a produce washing system that was to be evaluated, that was to be tested, in order to then go and produce more of these for the market, we could look to qualify those materials. So in turn, kind of this claim ended up being a lot larger for this company than they originally expected. And, that was really helpful for them, I think, going forward. And, now with that understanding, they can look to kind of incorporate this claim going forward and just understand that those funds, could be available based on their kind of R&D activities in the previous years, moving forward with 2022 and beyond.
What a great feeling to go into this thinking. I think they went into it thinking they were going to get back a really, a decent amount, but I think they went back and they got far more than they thought they would. Whoever that CFO was, I'm sure it got a bonus that year.
Yeah, exactly.
All right. Well, who's ready for more? I know I am. Next, we have an engineering services firm. And I think, Evangelia, did you have the pleasure of working on this one?
Yes, this was one of my clients. So they provide engineering services for a variety of industries like aerospace, automotive, industrial manufacturing, medical. So some of the things they work on are 3D scanning and metrology and data processing. So they were able to claim a pretty substantial credit. This was over 2 years. And they had a lot of cool projects, but a couple of that I chose to kind of highlight here was, so one of them was a robotic painting solution for aircraft coating. So basically this coating was applied on aircraft, and what they were hired to do was to develop a solution where this coating could be machined down to the desired thickness, just because it could be, the thickness could be inconsistent in different areas. So an added complexity there was that the robot had to machine hard to reach areas, such as inside an inlet duct, and still maintain that high degree of accuracy as well as repeatability. So they also needed to use long arm tools for this type of task. So that was an additional challenge for them because the tight tolerances would exacerbate alignment errors. So this was really an effort to kind of fine tune the tooling that was necessary to perform the task, and develop different workarounds to access these hard to reach areas. So that was one project that was really interesting. Another project was developing a mobile robot prototype that would be equipped with LiDAR mapping and localization system. They couldn't deploy cameras in that setup, just according to the specifics of the project. So they had to develop this type of navigation system that would be based on LiDAR. So it was really designing the locating, tracking, and guidance software that needed to run in the background of the client's process control software. And then they had to resolve various issues that had to do with the noisy data that was acquired by the LiDAR. So they had to develop this complex solution using 2 different systems to kind of tackle the different complexities and acquire the necessary quality of data that was required to perform the task. So, so yeah, overall a very interesting client to work with. They had many different projects, all contract based. So I have another, and we can switch to the next slide.
Actually, just a quick question.
Yeah.
So when you were working with this client, how did you go about getting a lot of this project information? Was it through speaking with people? Did you review like project notes they had? How'd you guys get all the necessary information?
Yeah, so it was a combination. Because we didn't want to take up too much time. You know, the company stakeholders that we spoke to, they're all busy people. The lead engineer was constantly in the field, so we didn't want to take too much of their time. So what we did is they provided a lot of supporting technical documentation, such as proposals and SOWs that we were able to review and extract a lot of the necessary information. They had some readily available Excel data that detailed a lot of the projects that they worked on. So these were classified as, R&D versus non-R&D, and then we were able to hone in on the ones that were relevant for the claim. So after we narrowed down the list and extracted as much of the data as possible as we could from the supporting documents, we held interviews. So this required a couple of hours of the president and director of business development, and 1 hour of interview time with the lead engineer, and we were able to wrap up the claim for them.
Nice. All right, well, let's hear more examples.
Okay, and then this client that I chose to highlight here, very interesting as well. They specialize in machine vision and artificial intelligence and robotics. So the company is a vision integrator. Basically, they work with a variety of industries as well, defense, electronics, medical, pharmaceutical, food and beverage, automotive manufacturers, you name it. So we had a similar approach here in terms of collecting the documents. It was also facilitated by some time tracking data that the company held. So that's always the gold standard. It's not a requirement, but it's really great when that's available. And a couple of projects that I'm highlighting here because we had many projects that we qualified. So the first one is really relevant to the times that we are currently experiencing. So it was related to COVID, and their client wanted basically to develop a solution to detect potential COVID-19 infection, and deploy a methodology that would basically not necessitate the use of more aggressive contact testing. So elevated body temperature had been shown as an adequate marker for detection and quarantine procedures. So that's basically what they honed in. So they developed this automated fever detection system and temperature tunnel system that would basically isolate a person's face, and specifically the eyes inner canthus area, from where the temperature measurement was taken. It's found to be a reliable location to take that measurement. So they had difficulties, being able to isolate those features when you're dealing with a diverse human sample pool. They had to also be able to isolate the mask because everybody wears face masks. So they had to use the biometric data and extract, isolate the face mask, and then find ways to tackle with varying ambient temperature, different thermal disturbances that you can have from the air, or turbulences. So that also has to be isolated from the thermal reading data collection. And, another big aspect was basically calibration, and being able to tackle that, being able to develop a referencing system. So basically a calibration target to achieve the calibration. So all of the development was focused around those different aspects. So that was one project that we worked with. Another one that was really interesting was for this within a manufacturing setting. They had these different feeders, and they wanted to develop a vision inspection system to identify and track the playing cards that would come out of these feeders. So they had to implement a system using machine vision. It had to meet the client's manufacturing volumes. There was complex data that needed to be processed and analyzed from the machine vision system. Various cards and combinations, and all of that at high speeds within that industrial setting. all of that had to be integrated. So the different feeders that were used in that setting, all of that data had to be integrated and processed in one central basically system, and all of that had to be done while minimizing latency and being able to ensure that the system was scalable. So if they wanted to add, for example, additional feeders and so forth. So they implemented a really sophisticated solution here. So explored OCR recognition, and they also explored, machine pattern recognition and other learning techniques such as deep learning. So, implementing a neural network basically. So very sophisticated solution, and then a lot done on both the software and hardware side to make sure all of these processes were happening at high speeds and latency was minimized. And then lastly, another system that they implemented for a different client was a vision system to do quality control for siding board production. And they had to automate this process. The client wanted to basically to remove the human factor completely, increase quality. So they were also, fabricating different siding board products. So this system had to accommodate any variation in length and thickness and groove patterns. So a lot of different features to take into account. It had to be fully automated. Any defects and deviations from the desired dimensions had to be detected with high accuracy. The production environment was a harsh environment. So both the vision system and the corresponding hardware had to be able to work within that environment and achieve high inspection reliability and accuracy. And again, they also had to properly calibrate the system and meet all of the required specifications.
Wow, it seems like they had a lot going on there. I'd say this is like pretty impressive that the interview time was 2 hours and it yielded a $270,000 credit. That is a pretty impressive return on time investment, but clearly a busy firm. Wouldn't you guys agree? And just we had a couple questions while we were in the chat, which I answered, but I do want to highlight that today our conversation is focused on engineering, but this is a tax credit that's available to any industry that is trying something new. To really put it simply, there are over 70 industries that qualify. So we're happy to tell you guys all about it if you'd like to schedule time to make that happen. And I think they just put in the chat box. If you guys have a question, pop it in here, or you can unmute and join the conversation. One thing I did just want to touch on is, while the R&D tax credit is a tax strategy that can be put in place to continually innovate, there is also a credit that we specialize in called the Employee Retention Tax Credit, which is in response to COVID. So it's helping businesses get back on their feet if they had to either shut down completely or partially as a result of COVID in the city or state that they live in. If there was a mandate, if their revenue was reduced by 20% per quarter or more, that will also put you into eligibility for this. And if there were disruptions to the typical workflow that had a significant impact on the business, that'll also put you into qualification. That's worth a conversation so we can figure out exactly how it was, how the impact was. But if you qualify, you can get up to $26,000 back per employee. So there's a lot of misinformation about the employee retention tax credit out in the world. So please, if you have questions on it, come to the experts, and we are more than happy to answer them and see if we can help you guys. So if you have questions, thoughts, we'd love to help, and please unmute, ask questions. We've got these 3 wealths of information here to pick their brains. To touch on the question that Pam had earlier about the expenses. So the expenses that we can include within the R&D tax credit tend to be materials, raw materials, wages, subcontracted expenses. So Pam, we'd probably need a little more info, but I do think that that's a cost you guys could include. So any thoughts you guys have that you'd like to share about projects you've worked on, or, you know, the engineering sector overall?
Yeah, so I kind of coming from my background, especially in the architecture, engineering, and construction realm, there's definitely a lot of activities that, when you're out there performing them, you may not think they qualify. But the great part about this credit is that the definition for R&D for the R&D tax credit is a lot broader than what one might typically think it is. And so it's definitely worth having a conversation about, to see if there are kind of projects that you may not think are R&D, but could be qualified kind of under this definition.
Well, thank you everyone for your time today. And if you have questions, or if you want to pick anyone's brain on anything, you can use this link here in the chat to book time, and we'll be happy to chat with you. Thank